All right, this video is for our Intro to Polynomials lesson, and it's broken up into two parts. This first section is a review of factoring, and then the bottom section is writing polynomials from roots. So real quickly, let's talk about what this word factor means. If I have this number 16, and I say, you know what, that's the same as 2 and 8, because 2 times 8 equals 16. This 2 is a factor, and this 8 is a factor. So factors are things that are being multiplied. Now the question becomes, how do I break down something into factors if there's variables involved? And that's what this top section is a review of, factoring algebraic expressions. And these four examples are good indicators of a few different methods. This first one is for greatest common factor. The second one is for difference of two perfect squares. So DOS is difference of squares. GCF is greatest common factor. This problem is a trinomial with an a value of 1, which we're going to talk about two different ways you can do those. I'm going to call this the cross method, which you'll see why. And then this one is a trinomial with an a factor that is not 1, which we're going to do two different ways as well. So in this first example, we are finding the greatest common factor of these two terms, which is the biggest value that will divide into both terms. So we're going to do this for the number or coefficient portion, and we're going to do it for the variable portion. So looking at 15 and 5, the greatest common factor for them is 5. And looking at the variables, the greatest common factor is x. That's the most x's that they both have. They both have at least one x. So here's how I'm going to rewrite this next step. I said that it was 5 and x as the greatest common factor. Do this. And in parentheses, I'm going to put what we have, the quotient of what we have after we divide that out. So dividing 15 by 5 gives me 3. Dividing x squared by x is x. And then here, when I divide 5x out of itself, that leaves me 1. Now, normally, I'm just going to go from here to here and do the division part in my brain. But technically, this is what's happening. Right, I'm dividing 5x out of those two things. So if it helps you to write that, and then you can simplify the fraction. So 5x is what I divided out, and then after simplifying here, I have 3x, and after simplifying here, I have 1. And here's your big tip for checking if your work was correct. Do distributive property, right? 5x times 3x is 15x squared. 5x times 1 is 5x, and that's what we started with. Right, so y equals 5x times 3x plus 1. And this is factored form. I have 5x is one factor, and then, well, actually 2, and then this whole group is another factor. So that's 3x plus 1 is a factor. So this is now in factored form. Let's go on to this next problem right here. This is a difference of squares problem. This is a very particular setup for this shortcut. What's happening here is I have two things, x squared and 16, that are perfect squares, and they're being subtracted. When that happens, we can factor this into x minus 4 times x plus 4. Right, so there's one factor, x minus 4, and my second factor is x plus 4. Now, once we're used to it, we'll just do that mentally from here to here. But you can, if you want to see some work that you could do to help yourself out, I like to do this sometimes. I'll square root the first thing and give me x, square root the second thing and gives me 4, and then I just know I need to make a subtraction version and an addition version with those two things. And then over here with the trinomials, we have three terms now that we want to get into factored form. So I always start with this, cross. I need two numbers that multiply to AC and add to B. So the A, C, and B are the coefficients on your x's. They don't include the x's, it's the number in front. So A is, in this case, 1, so there's A. B is the -4, and C is the -5. So if I want the product of A and C, it's 1 times -5, or just -5, and B is -4. So two numbers that multiply to -5 and add to -4 are -5 and 1. And here's what I'm going to do with these two things. I'm going to take my original expression and I'm going to rewrite the middle term using these two with x's on them. So instead of -4x, I'm going to write -5x plus 1x. Okay, that's the same as -4. It's just written differently. And then my first and last terms are going to stay the same. And the reason why I've done this is now that I have 4 terms, I can do grouping. So if you remember, grouping goes like this. You have to have 4 terms, and you group the first 2 together and the second 2. Notice how whatever sign this is in the middle, I'm including that in the second group. So now what I'm going to do is the same thing I did here, this GCF method. I'm going to GCF this group, and I'm going to GCF the second group. So in the first group, the coefficient here is a 1. So 1 and -5 don't have a common factor. So I go to the variables and I say, what's the most x's that they both have? And they both have at least one x. So that's my GCF. I'm going to divide it out of those two. So I'm left with 1x here and -5. And if I distribute to check, you could see why that works. Then in the second group, it feels like there's nothing in common. 1 and 5 don't have a greatest common factor, and they don't have any x's in common. So really the only thing they have in common is 1, because 1 goes into 1 and 1 goes into -5. So that's their GCF plus 1. And then when I divide 1 out, nothing changes. I still have the x minus 5. So now I'm going to look at these two groups together and compare them. You see how they both have an x minus 5? That's their greatest common factor. So I'm going to do the same thing as I did over here. I'm going to write down their greatest common factor. So x minus 5, just like I wrote 5x here. And then in parentheses, I'm going to write what's left over, the quotient, when I divide out the x minus 5. So when I get rid of the x minus 5 in this first group, I'm left with x. And when I get rid of x minus 5 in the second group, I'm left with a plus 1. So I have x plus 1 left. So that is factored. X minus 5 is a factor, x plus 1 is a factor. Now here's a shortcut, and this shortcut is just for when a equals 1. I want you to notice that I got -5 and 1 here, which is the same thing I got when I did this cross. So if you can remember that the shortcut only applies when a is 1, then feel free, once you've done the cross, to come straight down here to factored form and skip the grouping part. So now here's how we would do grouping when a does not equal 1. So I start with the cross, what multiplies to AC and adds to B. So in this case, A is 3, C is 4, so multiplying them gives me 12, and B is -8. So -6 and -2 will multiply to +12 and add to -8. So I'm going to use these two numbers to rewrite my middle term into 2. So I've got -6x, -2x. Okay, that's the same thing as negative 8x. This is written differently. And then the last term stays the same, the 4, and the first 2 stays the same. And now I do my grouping. Group these two. Group these two. In this first group, 3 goes into both 3 and 6, and x goes into x squared and x. So 3x is my GCF. And after I divide it out of here, I have 1x, and after I divide it out of here, I have a minus 2. In the second group, anytime this middle sign is negative, you want to include that on your GCF. So my GCF is going to be negative, and then 2x and 4 have 2 in common, and that's it. No x's. So negative 2x divide out a negative 2 leaves me positive x, and 4 divide out a negative 2 leaves me negative 2. So if you distribute this negative 2 through, you'll see why that works. So negative 2x plus 4. So now we look at the two groups and compare them to each other, and we see that they both have an x minus 2. So I'm going to take that x minus 2, that common factor, out of them, and put their quotient in parentheses. So in this first group here, when I take out an x minus 2, I'm left with that 3x. And then in the second group, when I take out that x minus 2, I'm left with negative 2. And so now here's my factored form. The first factor is x minus 2, and the second factor is 3x minus 2. Now we have a shortcut called swing method that we could do in both a equals 1 and a does not equal 1. That would look like this. So I'm going to do it for this problem right here. You start with the same, what multiplies to AC and adds to B. So we had this. But now take your negative 6 and your negative 2 and divide by the A value. And simplify those fractions if you can. So negative 2/3 doesn't simplify, but negative 6/3 becomes 2. So now I'm just going to go straight to factored form using those two numbers. Negative 2, sorry. X minus 2 and x minus 2/3. And the one that has the fraction, you're going to take the denominator and swing it to the front of that factor. So 3x minus 2, and then you have x minus 2. So this grouping method will work here. It will work here. It will work when you have 4 terms at any time. And it will also work for difference of squares if you let your b value be 0. So this grouping method will work a lot of the times. So what's great about that is you only have to remember one method. These shortcuts are here just if you can handle additional information in your brain and you would like a shortcut to work with. But if you don't want to remember shortcuts, grouping will do good in these other situations. So I'm going to do a second video where I solve these factors to get roots and then talk about the bottom of the notes. That's going to be a second video.